Okay, Deb, this is number 6 where we left off. I think I copied everything down exactly as I see it on the sheet. So, we're going to do the same thing. I'm going to call it implicit differentiation, meaning we're going to just take the derivative of each term. So I have 2x dx dt plus 2y dy dt is equal to 0. The derivative of 25 is going to be 0. So what I want you to see, clue into the fact that we got y equals 4, and we do have x left in here. If y is equal to 4, we can figure out that x, when y is equal to 4, x is equal to 3. Does that make sense? Plugging it right back into the equation. But if I'd be honest, x could not only equal 3, but x could also equal -3. So I think we're going to get two different answers depending on where, this is a circle, depending on where on the circle we are when we're talking about that y equals 5. So we're going to do kind of two problems here. We do a little bit of substitution. Notice I indicated that we're doing x equals 3 first. When we do a little bit of substitution, we get this. Then we know that 2 times 3 times 5 is going to give us 30 plus 8 dy dt equals 0. I'm going to move some things around, and I'll get that 8 dy dt is equal to -30, and therefore that is going to give me, when I do the math, I'm going to end up with dy dt is equal to, I'm just going to leave it at -30 over 8. Make that look like a 30. -30 over 8. And of course, we could rewrite that, and that could reduce to -15 over 4. And I think that's all good. I'm going to leave that there. And I'm going to take a look. Let me change the pen color. And this next one, if we consider when x is -3, we'll do exactly the same thing. However, we'll come out with, I believe that the only thing that's going to be different is that the sign's going to be different. So I've got 2 times -3, 5, plus 2 times 4 dy dt t equals 0. I can't really fit it here. Let me pull it back a little bit. Okay, there we go. Calculation, you'll see that dy dt, see if I can get that in here, dy dt is equal to, move the 30 over, the -30 over, it's +30 over 8. So basically the rate of change, if we have a circle, if you think about the picture, we have a circle centered at the origin with a radius of 5, and then so at +3 we have y equal 4, and -3 we have y equals 4. And the rates of change would have to be exactly the opposite. Like the slopes are going to be exactly different. So it kind of makes sense. So I think this one has two answers. Here's my brief notes about what's going on in number 7. 7, I would rewrite number 7 originally as x to the 1/2 power plus y to the 1/2 power is equal to 5. Then I do the same thing we usually do, take the derivative of each term. This one's going to be 1/2 x to the -1/2 power dx dt plus 1/2 y to the -1/2 power dy dt. And of course our 5 goes away. I don't know if the x to the -1/2 power is looking crazy to you, but here's a little thought bubble. If you want to think about it really quick, when we have x to the n, we know that the derivative is going to be, if I take the derivative of that, it's going to be n times x to the n minus 1 power. Therefore, if n is equal to 1/2, then when I subtract 1/2 minus 1, that n minus 1 is going to be a -1/2. Yeah, I don't know if you care. All right, just a thought. Okay, so something we needed to figure out is that when x is equal to, oh, don't want to erase that. Let's do that again. We need to calculate that when x is equal to 1, y is equal to, what do you think? I want to let you have a moment. You got it, 16, not 4. 16. When you take the square root of 16, you get 4. and then the square root of 1, I'm looking at these values up here. Take the square root of 16, you get 4. Take the square root of 1, you get 1. 4 plus 1 is 5. So we see that this point satisfies that equation. So we were actually given two values and not one. We were given 1, which is x equals 1, but we also were able to determine that y equals 16. So we're going to plug all that information in and see what we get. Done. This is what our plug-in situation looks like. And if you recall, when you raise something to a negative power, you're just going to take the reciprocal of that value. So the square root of 1 is just 1, which is what raising something to the 1/2 power is. And then when I take the reciprocal of that, 1 over 1 is still 1. So this is 1/2 times 1 times dx dt. So all of this has turned into that. And then this is 1/2. Now the square root of 16 is 4, but again, this is the reciprocal of 4, which is 1 over 4. That's what that negative exponent means. I'm going to multiply by 3. That's equal to 0. To get a little bit of space, but I think I recopied okay. And then we're going to just push through and solve for dx dt. So I end up with 1/2 dx dt is equal to a negative 3/8. Multiply both sides by 2, and then good things start happening. Dx dt is equal to negative 3 over 4. And I think I'm done. Okay, Devon, so here's number 8, which is probably the last one if we don't consider number 9. So as I was looking at this, I was trying to figure out, is this tangent of x plus 1, like one angle, or is this tangent of x plus the number 1? I'm going to go with the understanding that this is tangent of x plus a separate number 1, and then we're going to follow through. It might be beneficial to do the problem this way, where we will be taking the derivative of this term and this term with respect to t. And what I'm going to do is use the product rule over here, and this is just going to end up being our dy dt over here, and this will be 0. So here's what I got. So here's the way I think about it. I use product rule here, and that when I took derivative of that, it came out to be all of this. And then when I took the derivative of y, it just got dy dt, and of course the derivative of 4 is just 0. So you can kind of check your answer against mine and see if you have the same thing. Let me get some of this off. Oh well. Okay. So we have that. And what I'd like to do is start substituting in and see if something good comes up. Additional information. If I put in pi for tangent, the tangent of pi was like the tangent of 180 is actually going to be 0. So that's going to be helpful for us. Tangent of pi is going to equal 0. And therefore, if that's the case, then y times 0 plus 1 equals 4. And that's really y is equal to 4. So we have another bit of information to add to our problem. So y is equal to 4. And we can now proceed with our substitution. Okay, Devon, so here is the equation all plugged in as much as we can. A couple things I want to point out is that the secant of pi is -1. So we've got -1 squared here. Of course, we talked about the fact that y is 4. dx dt is what it is, plus 0. We already said that the tangent of x is 0. dy dt is given as -4. dy dt is given as -4. So all this boils down to 4 times dx dt plus -4 equals 0. And with some quick math, we get that dx dt is actually equal to 1. If I just plug every, am I lying? Yeah, it's actually equal to 1. Okay. And with that said, that's the answer to this one. I hope this was helpful. I hope that everything worked out with number 9. And send me an email or whatever, and I could explain anything on that page. And also, don't forget to find out what your responsibility is for the problems on Thursday. Have a good one, honey. All right, bye-bye.
Made with Doodlecast Pro.